Hi folks, so this is question 10. So Keith is playing hurling and during a match he hits the ball with his hurler. Okay, so this equation here represents the curve at which he hits it. So you'll know that if you hit a ball, doesn't matter if it's in hurling or what sport it's in, but if you hit a ball it'll rise and then it'll go down. So we've the negative 2t squared. So how high in meters was the ball when it was hit? So when t is zero. So it says when t is zero, so that gives you a hint anyway. You're just going to sub in zero for t, and you might be able to see your answer straight away, even because you know that um, the first two terms are just being multiplied by a zero. So minus 2 times 0 squared will just be 0. 5 times 0 is 0, and then you're left with the 1.2. So h is 1.2. And it's in seconds and meters. Yeah, so the answer, how high in meters, so it's in meters, so meters. Second part, the ball was caught after 2.4 seconds. So how high in meters was the ball when it was caught? So you're using this formula again. So the h is minus 2 times 2.4 squared plus 5 times 2.4 plus 1.2. So we're just subbing in 2.4 in instead of t. Then you have to go to your calculator. You can put all that into your calculator and it'll give you your answer straight away. So I'm getting 1.68, and that'll be in meters as well. So 1.68 meters. The third part then, when the ball passed over the halfway line, it was at a height of 3.2 meters, and its height was decreasing. How many seconds after it was hit did the ball pass over the halfway line? So we're asked to find t here really, because we're asked to find after how many seconds. So how many seconds means how long basically. So we're actually given the height here. It was at a height of 3.2 when this happened. So we're given the answer basically. So we put in a 3.2 instead of the height this time, equals minus 2t squared plus 5t plus 1.2. And now we have to move things around to turn it into a quadratic. So let's move the minus 2t squared over to the left. Let's move the 5t over to the left, and then let's move the 3.2 over to the right. So you're going to get 2 t squared minus 5t. Now, actually, I said move the 3.2 over to the right. Let's not, because we want to leave everything equal to 0. So let's move the 1.2 over to the left. So that's a positive 1.2. So when you move it over, you take it away from 3.2. So you're going to be left with plus 2 there. And that equals 0. So that's the quadratic then. And now we can solve it. You could use the minus b formula here if you want. There's different ways of doing this, and there's different ways of factorizing as well. That is the way I do it. But you're looking for two solutions here, so you want two numbers that multiply to give you 2, and then two numbers that will add to give you minus 5, but where one of them is being multiplied by 2 first. So it's going to be minus 2 and minus 1. So that'll work out. So we get 2t minus 1. That's our first bracket. There, like that. And our second bracket is t minus 2. Equals 0. And then we solve from there. So 2t minus 1 equals 0. So 2t equals 1. T equals a half. And t minus 2 equals 0. So t equals 2. So that's most of the way. You're almost there. You've got nearly all the marks stuff if you get that far, but you have to decide which one of them is worked really. So if we think back to the way it is, the way to think back to what the curve looks like. Okay, the reason we're getting two answers, uh, he hits the ball and it goes like that. So where the two answers come from are a half. So we'll just call that there a half, and we'll call this two. So the ball is going to rise and fall. So it has to be at 3.2 meters. Okay. It has to be at the 3.2 meters high twice because it'll be at 3.2 meters on the way up and on the way down. So it'll be at 3.2 meters shortly after he hits it, and then it'll go up, and then it'll start falling, and then it'll be at 3.2 meters again. So that's where we get our two answers from. So uh, in the question, it asks us, or it tells us that it's decreasing. So this is where it's decreasing. So it has to be the second one if it's where the ball is decreasing. So it has to be this answer. So that's why it's this answer. So it may take a little bit of thinking to get your head around, but basically the ball is at 3.2 meters high twice on the way up and on the way down. So on the way down is where our answer has to be then. You have to interpret it there for the last little bit. Right. So find dH dt is the next bit. So let's just write out the equation again. So h is minus 2t squared plus 5t plus 1.2. And hence find how long it took the ball to reach its greatest height. So first thing we do anyway, we just find dH dt. So that should be simple enough. We just have to differentiate it. So 2 gets multiplied by minus 2, so we get minus 4, and then the power goes down, so it's minus 4t. And then we just 5t will become 5. We just multiply 1 by 5, and the t power on the t goes to 0, and then the 1.2 is left out. So hence find how long it took the ball to reach its greatest height. So what you need to know is that when you've got any kind of a curve, if you find dH dt, if you differentiate it and then you let it equal to 0, that finds its maximum. So that'll find that there. So if we let our answer now equal to 0, it'll find this point here for us. So 0 equals minus 4t plus 5. And then we move over to 4t or the minus 4t. So we add 4t to both sides. So we get 4t over here equals 5. And then we can divide by 4. So t equals 5 over 4. And that's the same thing as 1.25. So that's the answer then, 1.25 seconds. Okay, so later in the game he hits the ball again, so now this is a new curve. So the time at the height of the ball after it was hit could be modeled by a different quadratic equation. So this time the ball was 1 meter high when he hit it. So if it's 1 meter high when he hit it, yeah, it's just going to be here that he hits it. So 1 meter high, so the 0.01. So the 0.01 has to be the first one. Its greatest height was 5 meters, which it reached after 2 seconds. So 2 seconds is here, so, and 5 meters, so that's the point there, 0.25. And then, so it doesn't give us really anything for the last point. It hit the ground without being caught. So it doesn't stop. That's just telling us that it doesn't really, the curve doesn't really stop anywhere. So the curve is going like this. So what has to happen really, just by kind of symmetry of any kind of ball going up in the air and coming down. It has to go up the same way it comes down. So it has to be two more. So it's gone two across here and it's gone up four. So it has to come down here. Yeah, so it has to come down here at 0.41. So the 0.41 goes in there. Part C then, he buys a new hurl, so it's a new type of problem again. He buys a new hurl. It usually costs €33, but Keith gets a student discount of 15%. So all we have to do here is find out what 15% of 33 is. So 33 times, you can do times 15 over 100 or times 0.15. And you just put that in your calculator and that'll tell you his discount. And that's 4.95. So 4.95, and then you can take that away from the 33. And that's 28 euro and 5 cents. Right, and this is the last part. So he also buys a jersey. This costs 49.50, including VAT at 23%. So the original price is at 100%, and then there's an extra 23% added on. So 23% VAT is a tax that's added on to stuff that you buy. So 23% will be equal to that. So that's where we're going to get our answer from. So all we've got to do then is we need to find 23% because 23% is the amount of VAT. That's what we need. So you're going to divide by 123 and then times by 23. So that'll find out what 1% is. So you divide both sides by 123. So 49.50 divided by 123. And yeah, we're getting a big long decimal. So I'm just going to put in what it says on the calculator here, which is 33 over 92. That's what I'm getting there. And then straight away, just on your calculator, times that then by 23. And we get 926 when you round it off. And then that has to be the amount of VAT, so 926. Give your answer to the nearest cent. So that's it. That's question 10. And that's the whole paper done.